This week in space. A space station crew prepares to return home earlier than expected. A lone planet is caught growing at a record-breaking pace. A snake-like robot shows how we may one day explore alien oceans, and new discoveries continue to blur the line between stars and planets. Relativity retested by a dead star. Astronomers using the Hubble Space Telescope have just repeated one of the most important experiments in modern physics, not with the Sun, but with a dead star only 17 light-years from Earth. More than a century ago, Albert Einstein predicted that massive objects bend space itself, causing light to change direction as it passes nearby. In 1919, that idea was confirmed when starlight curved around the Sun during a total solar eclipse, a moment that reshaped physics forever. Now, for the first time, Hubble has seen that same effect caused by a single star beyond our solar system. The star is a white dwarf called Stein 2051b, the dense, burned-out core left behind when a sun-like star reaches the end of its life. As it slowly drifted in front of a far more distant background star, its intense gravity gently bent the background starlight, shifting where that star appeared in the sky. The movement was almost impossibly small, just 2 milliarcseconds, about the same as watching an ant crawl across a coin from 1,500 miles away. But that was enough. By measuring that tiny deflection, astronomers were able to directly calculate the white dwarf's mass, about 68% of the Sun's mass. The result matches long-standing predictions about how white dwarfs are built on the inside, ideas first developed nearly a century ago as scientists tried to understand how stars die. What makes this especially powerful is the method itself. Normally, astronomers measure a star's mass by watching it orbit a close companion. But Stein 2051b's companion is far too distant for that approach to work. Gravitational microlensing changes that, essentially placing a single star directly on a cosmic scale. The findings were presented at the American Astronomical Society, and the team already plans to use the same technique again, next time targeting Proxima Centauri, our nearest stellar neighbor. More than 100 years after Einstein's prediction, the universe is still bending light and still rewarding those who know how to look. A rogue planet caught in a violent growth spurt. Astronomers have just caught a planet doing something no one expected, growing explosively, all on its own, far from any parent star. Using the Very Large Telescope, researchers have identified the most extreme growth spurt ever recorded for a so-called rogue planet, a free-floating world drifting through space without a star to orbit. The object, officially named CHA 1107-7626, sits about 620 light-years away in the constellation Chameleon. With a mass roughly 5 to 10 times that of Jupiter, it's still in the process of forming, and it's doing so at a staggering pace. Observations show the planet is pulling in gas and dust from a surrounding disk at a rate of about 6 billion tons every second. Even more striking, that rate surged to nearly 8 times higher than it was just months earlier. This isn't slow, steady growth. It's a sudden, violent feeding frenzy. That process, known as accretion, is familiar in young stars. But seeing it happen this intensely in a planetary mass object is something entirely new. The discovery was made using the X-Shooter instrument on ESO's VLT, combined with data from the James Webb Space Telescope and earlier observations from ESO archives. The results were published in the astrophysical journal Letters. During the burst, astronomers saw changes that have only ever been observed in stars before. Magnetic activity appears to be driving the inflow of material, and the chemistry of the disk itself changed, revealing water vapor that hadn't been seen previously. All of this blurs the line between stars and planets, suggesting that at least some rogue planets may form more like stars than we once thought. And this may be just the beginning. ESO's upcoming extremely large telescope is expected to reveal many more of these lonely worlds, and just how wild their early lives can be. NASA's snake robot that could slither into alien oceans. At NASA's Jet Propulsion Laboratory, engineers are building a robot designed to go where no rover could ever survive, straight down into the unknown. It's called EELS, short for Exobiology Extant Life Surveyor, and it looks less like a spacecraft and more like a mechanical snake. The idea is bold. Someday, a robot like this could descend through narrow ice vents on Saturn's moon Enceladus and explore the ocean hidden beneath its frozen crust. That destination is still years away. But designing for such an extreme world has already produced something remarkable. Built by a team at NASA Jet Propulsion Laboratory, EELS is a self-propelled autonomous robot meant to map, traverse, and explore places that have always been off-limits: steep crater walls, underground lava tubes, deep glacier shafts, and chaotic icy terrain. In its current form, known as EELS 1.0, the robot weighs about 220 pounds and stretches roughly 13 feet long. It's made of rotating segments fitted with screw-like treads that let it grip sand, ice, snow, or rock. Instead of rolling forward, it twists, anchors, and pulls itself along, sometimes sidewinding, sometimes curling into shapes the team nicknames Banana. Since 2019, EELS has been tested everywhere engineers can find extreme terrain: JPL's Mars Yard, snowy mountain ski resorts, indoor ice rinks, and deep inside Canada's Athabasca Glacier. In those glacier tests, the robot, or even just its sensor head, was lowered into vertical shafts, mapping ice walls in 3D with LiDAR while operating without real-time human control. That autonomy is the point. In deep space, delays make joystick control impossible. EELS has to sense danger, choose a path, recover from mistakes, and keep going on its own. The robot isn't part of a NASA mission yet, but it's already proving something important. If we want to explore the most alien environments in the solar system, the robots may need to think and move very differently than anything we've built before. NASA is moving up the return of SpaceX Crew-11 after a medical concern was identified during routine operations aboard the International Space Station. Here's the key. NASA says the astronaut is stable, and the agency is keeping details private for medical confidentiality. But after additional evaluations on orbit, mission managers decided the safest move is to bring the crew home earlier than planned.
So for over 60 years, NASA has set the standard for safety and security in crewed spaceflight. In these endeavors, including the 25 years of continuous human presence on board the International Space Station, the health and the well-being of our astronauts is always and will be our highest priority. Yesterday, January 7th, a single crew member on board the station experienced a medical situation and is now stable. After discussions with Chief Health and Medical Officer Dr. J.D. Polk and leadership across the agency, I've come to the decision that it's in the best interest of our astronauts to return Crew-11 ahead of their planned departure.
Thanks, Amit. First, probably goes without saying, but I'll still reiterate as a physician that I'm not going to speak about any particular astronaut or any particular specific diagnoses. I'd ask that we still respect the privacy of the astronaut. As administrator mentioned earlier, the astronaut is absolutely stable, so I have to reiterate that again.
This is also a milestone moment for the station program. Multiple outlets are describing it as the first time in the ISS's 25-year history that a U.S. crew rotation is being cut short specifically for a medical-driven return. The situation first surfaced publicly when NASA postponed a planned January 8th spacewalk, originally set to help prepare the station's power hardware for upcoming rollout solar array work. Crew-11 launched in August with NASA astronauts Zena Cardman and Mike Finka, JAXA astronaut Kimia Yui, and Roscosmos cosmonaut Oleg Platonov. Their Dragon spacecraft is docked, checked out, and ready, basically the station's lifeboat, always on standby. And while this is rare, it's not chaos. Early returns are a rehearsed part of human spaceflight. In fact, NASA says the crew is already going through standard departure prep, verifying suit fit, testing comms, and packing personal gear, while teams on the ground work with SpaceX and partners to pick the best landing window in the coming days. In the background, the station's work continues. Crew-11 has been supporting research in areas like advanced biomedical studies and in-orbit data processing, exactly the kind of science the ISS exists to do. Before we go, thank you for spending part of your week with us. Your curiosity, your comments, and your support are what make this channel possible, and they're what keep this journey moving forward. We'll be back next week with more discoveries, more missions, and more moments that remind us just how extraordinary exploration can be. Remember, the universe is vast, mysterious, and full of wonders waiting to be explored. Stay curious, keep looking up, and until next time, keep your eyes on the stars.